So let's see how the Descartes' rule of signs works for these polynomials. So on the first one, I have a positive, a negative, a positive, a negative, and a positive term. So that means I have a sign change for the negative 3, a second one for the positive 2, a third for negative 7, and a fourth for positive 1. So I have 4 sign changes. Which will mean that I have 4 positive roots, or an even integer less, which is 2 positive roots, or an even integer less, 0 positive roots. So for this next problem, I will count the sign changes, 1, 2, 3, 4, 5, 6, 7 sign changes, 7 sign changes, which means I could have 7 positive roots, or 5 positive roots, or 3 positive roots, or I could also have 1 positive root. On this last example, p of x equals x squared plus x plus 1. So if I look at my sign changes, I have no sign changes. I have a positive, positive, positive. So that will mean that I will have 0 positive roots. The Descartes rule can also be used to determine the number of negative real roots, since p of negative x is a reflection of the graph p of x over the y-axis. So this is the corollary to the Descartes rule of signs. The number of negative real roots of a polynomial x with real coefficients is the same number as the number of variations of sign of p negative x, or less than the number of variations of sign p negative x by a positive even integer. The first thing we'll do is we'll find p negative x. Since p negative x, x to the fourth is still going to be a positive x to the third. The second term is going to be negative x cubed. The x squared term is again a positive x squared. The x term will change to a negative x plus 1. So now if we count the number of sign changes, we'll have 1, 2, 3, 4 sign changes, which will mean that we could have 4 or 2 or 0 negative roots of this polynomial. So I'm going to look at the last one. Let's go ahead and rewrite it first with p negative x. The first term is going to turn negative, negative 7x to the third. The second term will stay negative, and the next term will turn to a negative, so it's negative 2x and minus 1. So if I look at the number of sign changes, there is no sign change. That will mean that this polynomial will have no negative real roots. So below you can see the homework assignment, so you could please get started on your homework after you listen to the lesson. Thank you.